Hello friends, welcome to online course on digital design using Verilog HDL. In today's lecture, we will try to understand the Verilog tasks and functions. Especially these Verilog tasks and functions, though they are very simple, yet they are very important. The meaning of the task and functions is very important for any beginner. So, let us start our journey by understanding what is the meaning of a task, what is the meaning of a function, and what is the importance of these two of design. Right. So, the tasks and functions in Verilog help to reduce the complexity by breaking up the large behavioral designs into smaller pieces and make the overall code simple and clean. Those who are familiar with the high-level languages, maybe C or C++ or anything, you might have seen that in many situations we use some procedures, functions, etc. in high-level languages also to avoid the complexity. These are also popularly known as subroutines. For example, in a program I want to find the value of log x, and I have to use this in my program at 2 to 3 places. So what the programmer will normally do, instead of using or instead of writing the code 3 or 4 places, he will define that as a function, and whenever he wishes to use or whenever he needs the value of log of x, for example only, he will simply call the function and use it. So it will reduce the space, it will reduce the complexity of the program. Similarly, in normal high-level language programming, we also use a word called procedures. What is the meaning of a procedure? A procedure will actually describe the methodology, how to manage something. For example, I want to find the average of 3 numbers. For that, I have a procedure. That means we take 3 numbers, we don't take 3 values. We'll write procedure, how to find. We'll take 3 numbers and we'll try to find the sum of these 3 numbers, and then we divide that sum by 3 so that I get my average. So I am giving the procedure here. I am not giving the value. Exactly in the same way, while writing a Verilog code, especially in the behavioral model, when the length of the code in the behavioral model is large or complex, I can divide that into smaller pieces by using these tasks and functions. This task is similar to your procedure in high-level language. So first every beginner has to understand very clearly the difference between task and function. He should have a clear idea how to use them in their program also, so that the program will become simple and clean. So let us start the introduction once again. So what I have written here, the tasks and functions in Verilog help to reduce the complexity by breaking up the large behavioral designs into smaller pieces and make the overall code simple and clean. It's important. Tasks and functions allow the designer to abstract the Verilog code that is used at many places, as I have just now told you, many places in the design. Tasks have input, output and in-out arguments, whereas functions have input arguments only. So values can be passed into and out from tasks and functions. This is the most important. A task is similar to a function. Actually, both appears to be very simple difference. But unlike a function, a task has both input and output ports. I am not calling here as output values, input output values. Please remember, we are calling here both input and output ports. Therefore, tasks do not return values. Why? Because task is only a procedure. Just now I have mentioned to make you to understand clearly. To find the average, to find the sum, to check whether a person has passed the exam or not. For that there will be a procedure. So the procedure will not return any value. So tasks are similar to procedures. That's what I have written in most programming languages. The purpose of a function here is to respond to an input value. For example, I have earlier taken to find log of x. Suppose I give the value of x into that function, it will give me the value. Correct? So clearly understand this. When I give the value of x into the log of, then it will return the value, single value, log of x. So here the purpose of a function is to respond to an input. What is the input at present here? For example, I say log of x, or I use some function like half adder. Half adder can be defined as a function. I can call the function, I substitute the value, it will give me the result. So similarly, a task can support multiple goals. So when I write a procedure, it may have multiple goals. Just now, as I have mentioned here, so when I take up a small program to write or to develop a task where I want to find out both average as well as sum, it can find the sum also average. So it may have multiple goals and can calculate multiple result values also. That's why I said repeatedly, it's like a procedure. It's like a procedure only. So it cannot be used in an expression. That is the most important, because it is only a procedure. I can't use this procedure in an expression. And of course, parameters may be passed to it and results are returned. Once we pass some parameters, then it may give the result accordingly. So now we'll come to the definition of task. A Verilog task is similar to a software procedure. It is called from a calling statement and after execution returns to the next statement. A task is defined within a module. Remember, a task is defined within a module using the keywords task and end task. You should remember, the beginners should remember this. So every task will start with the task, of course task name, and it will close by end task. Whenever I start with a task, then it should close by end task. And this task will be always called within the always statement, within the always block or always statement in the behavioral modeling. And local variables may be declared within it. So we can define the variables within this task itself. And the order of task parameters at the calling site must correspond to the order of definitions within the task. So these two must be matched always. That is another very important. A task may call itself. That's another important. A task may call itself or may be called by some other task, or be called from tasks that it has called earlier. All are possible. However, as in hardware implementation, there is only one set of registers to hold the task variables. You have to use only one set of registers to hold all the task variables. So the registers used after the second call to the task are the same physical entities as those in the previous call. Suppose I call a task twice or thrice, the register will be the same. The simulator maintains the thread of control. It will take care of the thread of control so that the returns from a task called multiple times are handled correctly. So that means it will remember the values of obtained from different tasks, right? So let us take the structure of a task. So it is in a module. So for module, this task I have chosen some name. Let us start task as the keyword and my task, name of the task. So as I have told you, it will have some inputs. Input A comma B, input C. So A, B, C are inputs. D and E are outputs. So here I have chosen some rich intermediate. So for 1, 2, 3. Now begin. So corresponding to these tasks, we'll write some statements. What is to be done here? So the set of statements that perform the work of the task. What is to be done with all these inputs? Because task is a procedure. So we'll write some statements here. Then what do we do? Now this is C is assigned with F for 1 is assigned to C, for 2 is assigned to D, for 3 is assigned to E. This is end. Then every task must be closed by end task. Since I have started with a module, it must be end module. So this is how we write here. Once again, you can see here. So if you see these things, so first structure, first I have defined the ABC, but I have not given the values of ABC. Suppose you substitute the values of ABC, then it will give the value according to these statements that I have written here. I may write anything here corresponding to these inputs. I may write any procedural statements. This is the most important thing, that is about the syntax. Here, only to make you to understand, I have taken example. Let us say task as a procedure. So task, what is its name? I call this as average. I want to find the average of some numbers. A, B, C are inputs. As you know, output is A, B average. And y is S sum. So AV average is defined as rich. So now first thing what I am doing here, earlier I have told you here, you have seen the statements assign S is equal to A plus B plus C. So what this will do? So this will give the sum. One goal. What is the next goal? Assign average is S divided by 3. This is called average. So what we do here is we try to find out. This is a procedure. I have not given the values of A, B, C, etc. Simply I have given a procedure here. Task. I have defined a task. So task with its name, input outputs, and this is the statements. End task. So this is another simple example to understand the meaning of a task. Now, Verilog provides some system tasks. Inherently, it has some built-in system tasks. So, task means some work, as I have told you, procedure. So, what are these tasks, system tasks? Normally, these system tasks will appear in the form always dollar. Here, we use the word dollar followed by the keyword task name. That is, so here, what are the examples that we have given that are supported by your Verilog? Dollar display, dollar stop, dollar finish, dollar monitor. Let us know the meaning. Here the name itself indicates display. It will give the procedure of displaying something. It will stop it will finish the program. It will monitor or control, take care of. So the variables, etc. So the names itself indicate that a task means it's a kind of work or activity or some procedure here. So let us take up the next one with some examples. Dollar display. What is dollar display? Dollar display is the main system task for displaying the values of variables or strings or expressions, whatever it may be in a Verilog program. How to use this usage? Dollar display followed by S1, S2, any number. So what are all these things? These can be strings normally within some codes. Quoted strings means within quotes, or variables or expressions. So the format of dollar display is very similar to the printf statement in C language. Very, very important. So a dollar display inserts a new line at the end of the string by default. By default, it creates a new line. A dollar display without any argument produces simply new line. If I don't give any argument, Simply it will go to the next line, new line. It will create a new line. So next, let us take some example. Dollar display within the quotes hello Verilog world. What it will do? It will display the quoted value. That means hello Verilog. Next, dollar display time, dollar time. So it will display the current simulation time of 2:30 here. Similarly, I want to display the port value, port ID, some in binary. How it will display? Dollar display ID of the port is, of course, percentage B binary port ID. What is this port ID? We have taken this as, because 4 down 0 means total 5. How it will represent the display? It will display as 00101. That's how we use this display. Another example, suppose I want to display some characters. Suppose this is a bus of 4-bit. So I want to display the width of this bus 10xx. How it will display? Suppose I write bus value is percentage of P binary in bus. So it will display bus value is 10xx. So that's how I use the first. Similarly, monitor, another task, system task. So Verilog provides a mechanism to monitor a signal when its value change. We use the monitor to control all these things. So usage $monitor P1, P2, P3, Pm. That means these parameters which we have given. So these may be variables or signal names or quoted strings, anything. So only one monitoring list is active at a time. If there is more than $1 monitor statement in the simulation time, the last $monitor will only be active. So the earlier $monitor statements will be ignored. Only the last, suppose if I use more than $1 monitor statements, only the last one will be active. That is the important thing. So the Verilog provides two tasks. What are these tasks? One is related to this monitor, $monitor on, $monitor off. So the task $monitor on will enable the monitoring in a simulation. Whenever I wish to stop or disable the simulation, I can use $monitor off here. Monitor on, monitor off. So monitor is turned on by default at the beginning of the simulation and can be controlled during the simulation with $monitor on, $monitor off. Say for example, after 100 units of time, I want to stop this monitor. I want to check the value. Then again, I can use task $monitor on. Again, it can continue the simulation. So $monitor on and off, they will actually control. They will monitor or control this simulation operation. So this is about monitor on, monitor off. Similarly, $stop. So $stop is the task. $stop means it will stop the simulation. Remember, I use a very normal word, temporarily. Just like as I earlier told you, $monitor on, $monitor off. Here, instead of that, I use simply stop. That means when a simulation is going on at 100 units of time, I want to note down the result. Then I use $stop 100 at 100 units. That means the simulation will temporarily stop. Then what is the difference between $stop and finish? $finish means it will terminate the simulation. That is the basic difference between stop and finish. I think I have given an example here, you can see. So there is a total of 1000 units of time. The simulation has started at clock is equal to 0. Reset is 1. After 100 units of time, I have written $stop. That means you stop the simulation at 100th unit of time, and again at 900 units of time. After 900, then you terminate the simulation, end. That is the difference between stop and finish. Similarly, let us now consider the next important concept in Verilog called functions. As I already explained in the beginning, functions are similar to tasks, except that functions return only a single value. I have told you repeatedly, single value to the expression from which they are called. When I pass some input, value, not port, input value to a function, it gives the result. It gives me the result. So like tasks, functions provide the ability to execute common procedures from again within the module. A function can be invoked, means called, from a continuous assignment statement from within a procedural statement and is represented by an operand in an expression. So I can call this function within the procedural statements or procedural block in a behavioral model. So let us take up. Functions cannot contain delays. That is the fundamental difference between a task and function. Just now we have seen $stop, $finish. So where after 100 units you have stopped, after 900 units of time you have terminated. But whereas in functions it will not be like this. This is simply just similar to your C programming where you have defined main function, average function. That means, so it indicates some activity function, which that means it has a specific application. It has a specific use. As I have told you in the earlier slides, I can write a function for mux multiplexer. I can write a function for full adder. That means when I call this full adder, it gives me the result when I give the input values. So functions must have at least one input argument, at least one, more than one also. But it cannot have output or in and out arguments. That's very important, because at the end it will give the values. So functions cannot have delays. Functions cannot have output or in-out arguments. A function is invoked from an expression. The function is invoked by specifying the function name together with the input parameter. I have to give the input. For example, if I invoke a half adder function, then I have to give 2 inputs, 1 carry. That is 3 inputs I have to provide. Then it will give me the result. So the syntax is below: function and function name followed by this expression 1, expression 2, expression n. There may be n expressions. This is the syntax of a function. There may be range of numbers or a type, whatever it may be, followed by the function name. Next, input declarations, and if there are any other declarations, other inputs, etc. Begin, you write some statements, then end for these statements, end for this function, end function. This is a common syntax of your function. So here I have taken an example, as I have told you, a simple example of mux multiplexer, as you know. So here for a multiplexer, what are the inputs? A, B, C, D are the inputs, 4 inputs, and there is a select line. It is a 2-bit, 1 down 0 means 2 select line. Yes, 2 options. So then I am using here case. You need not use this, you can use anything. Just a case step. Case select. When the size is 2, it is a binary, as you know. When it is 0, 0, mux is equal to A. That is, A is the output of this function. B is out because mux is the name of the function. Remember, here mux is the name of the function. Now A is equal to the function. B is equal to here. C is equal according to this default. When I do simply B of x is taken as a binary, that is unknown value. X means, as you know, unassigned or unknown is given to mux. That means it will be. So end case, because we have used a case statement here, and function for a half adder. So what is this function half adder? Again, same module, function half adder. This is the name of the function. This is the module. I am taking the entire program. A and B are chosen as rich. Sum is 1 down 0. It is also chosen as a range. Initial begin. So I am defining, that is assigning sum is equal to half adder value of within size is 1, its value is 0. This is also 0, half adder. So display A is equal to 0, B is equal to 0. See out, sum is defined as this. It's a percentage. B means binary value. Sum is defined as a binary value. Display the sum like this. Value of A, value of B, sum. Sum is equal to half adder of 1B0, 1. That is 0 and 1. So I am substituting the values of 0 and 1. Earlier we have substituted 0, 0. It will give me the sum. Now I am substituting 0 1. Similarly, so in this function I am applying sum. Here display this sum. When it will display? When it is 1 0. Earlier it was, you see once again, first the values were AB values were 0 0 0 1, next 1 0, next 1 1. Every time it will display the sum. So end. So this is defined. Function is totally explained. Now you can call this function. Function 1 down 0 half adder input AB sum is reached begin. Now for these values using the case statement I have written this sum. So here I have called this and I am using the values. It will display sum is equal to half assigned to half adder. End function end module. So this is how we have used. We have defined the function and we have called the function in any module. So that's why I have both end module and end function also here. Similarly, I can, as you have seen earlier, I can define a mux and I can use this mux in some other design by calling. So the basic difference you can understand here, that is between the task and function. Now, once you understand these things, let us take the differences between functions and tasks. As you have seen in the earlier slides, a function can enable another function, but not another task. A task can enable other tasks as well as functions, because task is only a procedure. A task can enable either another task or function. This task, that's the most important thing, because a function cannot enable a procedure. That is the most important thing. Function always executes in zero simulation time. That's very important. Whereas, as you know, in the tasks you can have the time delays. It can execute in a non-zero simulation time. You have seen already dollar time, dollar everything, dollar stop, dollar finish, etc. Functions must not contain any delay. Just now, as I have told you, this one. That's why, because it starts at 0, so it may contain delay, event, anything. Functions must have at least one input, definite, as you know. So suppose I have a half adder, I should have 3 inputs. So at least one means it can have any number. They can have more than one input, but there will be no output. So tasks may have 0 or more arguments of type input, output, or not values. Ports, it can have ports like input, output, or in out. So always it returns a single value. Function always returns a single value, whereas tasks do not return with a value but can pass multiple values through the output and in out arguments, because it is a procedure. Okay, happy learning. Thank you for watching. I wish you all the best.